Okay, so the question we're going to do is the one in the top left hand corner of the screen here. It is figure 18.48 with a hyperboloid revolution, and we're going to start by looking at the measurements. They are given in meters, so this is a physical realistic object, and the scale that we're going to be drawing it at is 1:500. So what we're going to do is we're going to take that 60 meters. Okay, I hope you can see this on the calculator. We take 60 and we multiply that by 1,000. Now, why do we multiply that by 1,000? The reason we multiply that by 1,000 is because there's 1,000 millimeters in a meter. So that gives us 60,000, and then if we divide that by 500, we end up getting 120 millimeters. That's what we're going to be drawing at. Okay, and a little quick tip then, once we've that one done, we notice that the 60 meters is doubled essentially, so we have 120 millimeters. The 45 can be doubled to 90 millimeters, and then the 23 can be doubled to 46 millimeters. Okay, so that's just a little trick or tip there for you once you've worked it out with the calculator. So we're going to start off by doing this here now, and we will start with our center line for the hyperboloid revolution. Okay, the plan then is going to be a diameter of 45, which means an overall measurement of diameter of 90 millimeters. Find my midpoint there. So this is the very, very central axis. If we set up our, just going to zoom in on that a little bit. If we set up our compass to this central point here and to our diameter, that gives us our base circle and our top circle. And then our throat circle, which is the narrowest measurement of the hyperboloid revolution, is diameter 23. Again, doubling that is going to be diameter 46. But I'm going to do radius 23 here. So radius 23, that's set my measurement for my compass. And that's the plan view of my throat circle. Okay, so now we're going to transfer these measurements up to our front elevation. Okay, so the overall height of this is 60 millimeters, or 60 meters, which again, when we scale it back using our calculations, is 120 millimeters. So marking that off, that gives me the highest point there, as you can see. Okay, the top circle is going to be up there. The throat circle is going to be half of that, which is there. So we now know the two locations for the throat circle. So this here is my throat circle. This here is my top circle. Okay, so just putting those pencil lines in nice and light. We have our top circle, base circle, throat circle. And now what we're going to try and find is the hyperbola that goes in here. Okay, so the first thing I'm going to do is we're going to take our throat circle in plan view. Okay, so what you do in one view, you must do in the other. So we're going to take our throat circle and we're going to first off draw what's known as the asymptote. Now the asymptote is a vertical cut. So I'm taking this plan view and I'm slicing straight down vertically down through the object and removing the front half. And by removing the front half, then what we'll end up with two lines. So this point here is on the base, and that line will go and contact the throat circle here and then touch the top circle here. That's known as an element. Okay, or it's a known line. It's known as an element that will stretch from the base all the way through that center point and hit the top circle. So what we're going to do now is we're going to transfer that in order to find it. So we bring that mark to the base circle, to the base circle. And with our red pen, we're going to join it through the central point, from the base circle, through the center of the throat circle, up to the top circle. So there's one element that's part of our asymptote. And our other line here from the base circle through the central point up to the top circle is the other asymptote. Okay, so that's an element or a line that stretches from the base to the top circle, base to top circle. Okay, so this line, this horizontal line here that's in contact or tangential to the throat circle is those two lines. Okay, and what we're going to do is we're going to use those in order to get or solve our hyperbola shape here on the outside. So what we're first going to do is we're going to now move to the front elevation view, and we're going to take some horizontal cuts. And for me, what I'm going to do is I'm going to cut these at heights of 15. So we'll have 15, 30, 45 and 60. Now I'm only going to work on the bottom half because the top half is the exact same, it's symmetrical, and once we can do the bottom half we can then mirror or use symmetry to copy our lines and shapes up to the top half. Okay, so once I have the asymptote, and again just for the illustration purposes I'm just going to level, and we go right here. And then just to link to other subjects, you might come across asymptotes in maths as well. Okay, or maybe some science. So what we're going to do now is we're going to take these three heights and we're going to cut. Imagining that we have the object solid and we have it solved, we're going to cut across it horizontally. So this is cut number 1. Okay, and what we're trying to find is we're trying to find this hyperbola here. So what we're going to do is we take cut 1. Now what do we know of cut 1 to help us here? Well, we know if we were to cut this object horizontally, it would create a circle. So we need to know what size of circle to draw. So when we take that cut, the only point that we know is actually the point on the asymptote, okay, on either side. So what we can do is we can take that point, what you do in one view you must do in the other, or where one point is in one view it must be in the same location in the other view. So we're going to take that point on the horizontal cut on the asymptote and bring it down to the asymptote in plan. Okay. So now we have a location. What we're going to do then is we're going to create that circular cut that the horizontal cut would give us. Okay, and for the first one here I'm going to draw the full circle. Generally I wouldn't do that, or going forward I won't do that because it's just a waste of my time and it's not going to find, you don't need to be putting in extra work if you don't need to. So that blue horizontal cut is that circle. Okay, so that circular cut there is what is created. If we cut at this height, it's going to create that circle. And that there is a point on our extreme generator that we can now bring up to the same height, and that will find us a point on the hyperbolic curve. So the hyperbolic curve going from the top circle to the throat circle to the base circle is that line there. So we're going to be finding points along this line here and bringing them up to the exact same height that we cut them at in order to find that hyperbolic curve. So now what I can do with this point is I can bring it directly up to the exact same height as I cut at. Okay, so what we did was we brought it from the asymptote here down to the asymptote here, horizontal cut, creating a circle. Where we need that circle is on the extreme generator. And just again, for the purposes of this is going to be our extreme generator. That is the shape that we want, with the line that we want to find it on. The extreme generator is the widest possible shape possible, or the widest part possible of this shape when we cut it vertically there, that we'll see in front elevation. Alright, so we're going to bring that up here to this height, and that is then a known location on our hyperbola. We already knew 3, we knew 1, 2 and 3, and the same on the other side, 1, 2 and 3, and what we need to find is points in between those, because it's too large of a gap to randomly sketch. Okay, so now what we're going to do is we're going to do the same principle for cut number 2. We're going to take cut number 2. Okay, we're going to take a location on that cut that we know, which again is on the asymptote, and we'll bring that down to where it is located in plan. Bring it down to the asymptote here in plan. Now this time I'm not going to draw the full circle, I'm just going to bring it to where I need it, which is to the extreme generator. Rotate that around to here. Gives me a point there that I can bring up to the exact same height as cut number 2. I'll bring it back to the cut number 2. So this is on the extreme generator. I can bring that back up there, and that solves another point. Okay, we repeat that process a third time for cut number 3. Cut number 3. We're going to bring the point on the asymptote down in plan to where we know it is in plan, which is on the asymptote. So that comes down. We're going to swing it around with our compass, again from the central point, the central axis, swinging this around till it hits our extreme generator. To here, on the extreme generator, which is the outside shape that we're trying to create, we'll bring that back up to there. This point was coming up as well. Okay. So now we have 1/4 of our hyperbolic curve. Now what I can do is, all you need is 1/4 because it is a symmetrical shape. I can use symmetry now to copy it over to the other side. So continue that line up there, continue that line up there, continue that line up there, and all I need to do is use this as my symmetry line and take my measurement and then copy it up there. Take the measurement of the next point, copying it up here, measurement of the next one, copying it up there. Now it'll give me a nice, neat hyperbolic curve, which I can now sketch in. Throat circle. And once I have it neatly sketched and nice and accurate, I can go over that a little bit heavier to make it stand out to the examiner. How do we do it on the other side? Well, we use the same technique. We use our symmetry method to get it over on the other side. We already have our heights there. So I'll take my distances here. If you don't think that's enough points to get your accurate curve, what you need to do then is you need to do a few more cuts using the same technique to get an accurate curve. It is important to communicate a nice accurate curve, and if you have a flexi curve, this would be a great time to use one now. Okay. Again, going over this. Okay, so that would be our solid object, solid hyperbolic paraboloid, or sorry, hyperboloid of revolution before it was cut. And now what we're going to do is we're going to take 35 degree angle and we're going to cut the hyperboloid revolution. Okay. So we'll take it here and we'll go from 0 all the way around to 35. Use my little mark here. There is my cut. Okay, it's called S. And what we're going to do now is we're going to use the same idea of the horizontal cuts, and we're going to be creating portions of circles in order to show the shape here. So what's actually happening is this whole part is being removed, okay, and we need to show the what's going to end up being an elliptical shape here for the cut. So as you can see, I already have a couple of horizontal measurements here that I'm going to use, and I'm just going to put them in blue. So that there is what's left. That there is what's left. That there is what's left. This here would be a point and a point. So the first thing I'm going to do is I'm going to bring down the two limits of S to my extreme generator. Down to here. And we have the end point there. So this is where S and S. Okay, there are 2 points that are being created. Now, we're going to take this horizontal cut, and instead of having a full circle now, we're removing this little portion here. Same here, instead of having a full circle, we're only keeping this bit and removing that bit. And again, that's what we're going to be showing. So at that point there, along that cut, on this circle, there should be 2 points. One at the front, down here, and one at the back. Okay, so we're going to call this cut number 4, cut number 5, and cut number 6. So we're going to take cut number 4, which we already have, and we're going to draw in a circle. Now, maybe if I can... Okay, so I'm going to draw the circle in blue pen, just in order for you to see it. Okay, and this side I'm going to work on the left hand side of the plan view. So I'm going to take down the measurement of 4 to my extreme generator. I'm going to number it in as 4. I'm going to take down 5 and 6. Okay, so 4, 5 and 6. Now, if you notice, circle 1, which is from here to here, is the exact same size as circle 6. However, we've removed this portion here. So if I work on that first circle, and again, I'm just going to put it in blue here, just so you can gain an understanding. Okay, this is what the circle would be. This is what it would look like if it was fully in existence, which it now no longer is, because it's been cut by SS. So That is what it would have looked like. However, on that cut, we're going to take down a second cut here, which is this point, and we take that point down to that circle, and we mark off the front and the back of that circle. So there's that point and that point. And that is what that's what is remaining of that circle. Okay. So we now have 4 points on our elliptical shape. We have S, 1, 2, and 3. Okay, so we have 4 points. And if we wanted to call this A, this would be A and A. Again, labeling is going to help us to make sure to get this right. So we've A. Now, on horizontal cut 5, we'll call that B. There's going to be 2 points for B, remember? Front and back. And C, 2 points for cut C, front and back. So, we have the measurements for circle 5. So what I do is adjust my compass. And you notice I'm not doing a full circle here because I don't want to ruin the drawing or have the drawing too compacted or have too much information on it. But that would be the portion of the circle had this hyperboloid revolution been in full. Where is that being cut off by the cut SS? We bring it down. We mark it in here and here, and that's B and B. We do the same thing for horizontal cut 4 and C. So on the horizontal cut for 4 first, that is this measurement here, again being represented by a blue circle. Okay, and on that blue circle, where is SS cutting it? Well, it's cutting it here, so we're going to bring that down. And wherever that cuts the blue circle, being here and here, is our points C and C. We join up all those points and that will give us that elliptical shape that is going to be created by the cut SS. And again, going over it nice and heavy so it stands out. And we're just going to colour that surface there in. Yellow, just so you can see it. Of course, the yellow has to go on me. But that is our cut surface SS now, okay? Now, in this question as well, we're asked for the true shape of SS. Now, to get the true shape of anything, you must look at 90 degrees. Okay? So, if you're taking a penalty in any ball sport, or let's say basketball, if you're taking a free throw, the advantage is because you're 90 degrees to the backboard or to the score line that you will see as much of the score and opportunity as possible. So what we must do is look at this surface at 90 degrees. So If we take our sliding set squares, if you have an adjustable set square, you can use this adjustable set square for this, but most of us don't. So we're going to take our 35-degree angle. I'm going to move that up out of the way. Okay. And we will draw in a parallel line here. And this is the axis of our shape. Okay. With our, let me just see if I can bring this down a little bit. So, take our cut line SS, come away from that slightly, and I'm looking for is 90-degree lines here. So there is S, this is going to be A, going to be along this line here somewhere. B is going to be along this line here somewhere. C is going to be along this line, and then we have the end of S. So, labeling this in, we have S and S. That is our major axis. Okay, the major axis, the longest length of our line from here. So, get our measurements for this this true shape. We're going to go back 2 views, and that means this is an auxiliary view, so we're creating that drawing from here. That's back 1 view, and this is back our 2nd view, and all we're simply doing is, there's our major axis there, the line SS. We're going to take our measurements from A here with a compass and mark them off either side for our curve, okay, for our elliptical shape. So we do that using the compass. So from our symmetry line, or our extreme generator, we take the measurement of A and we mark it off. Now it may run off the page here a little bit. It might be looking off. No, run off the page. We take the measurement of B. And again, I suppose this is important. I would be losing marks there for run off the page because I haven't lined it out properly. I haven't used the correct scale or distance. There's our B, and our measurement for C then is taken back 2 views from the symmetry line, or the axis line. There's C, and there's C. Again, we're going to label this to make sure that we know where our points are. There's A, there's B, there's C, C, B, A. And all we simply do is, again, sketch in a nice, neat elliptical shape. Always remember, the elliptical shape is a constant curve. And again, that is our true shape. Okay, so again, horizontal cut method is being used. The general principle of going back 2 views to get our information, and yeah, all the stuff that we would have used before, so shouldn't be too hard.